What if I told you that humanity's greatest journey hasn't even begun yet? For thousands of years, we've looked up at the night sky and dreamed of sailing among the stars, of touching other worlds, of discovering civilizations beyond our own. That longing is written into our oldest myths, whispered in our boldest scientific theories, and etched into the very fabric of our curiosity as a species. We are at heart explorers, and though we've walked on the moon and sent probes beyond our solar system, the dream of true interstellar travel, of crossing the unimaginable distances between stars, remains one of our most compelling and elusive ambitions. Today, we're setting sail on a voyage of the mind, exploring 30 breathtaking theories about the universe's very first interstellar travelers. Who were they? How did they journey across the cosmos? And what might their stories tell us about our own future among the stars? From ancient alien visitors to self-replicating AI probes, from generation ships carrying entire civilizations to beings made of pure energy, the possibilities are as vast as space itself. We'll wander through scientific hypotheses, philosophical wonderings, and imaginative speculations that challenge everything we think we know about life, technology, and what it truly means to journey beyond the familiar. This isn't just a list of ideas, it's an invitation to wonder, to imagine realities where light years are crossed not just with engines and equations, but with courage, ingenuity, and perhaps even a little magic. Whether these travelers came before us or are still ahead of us, their stories reflect our deepest hopes and boldest questions about existence. So settle in, open your mind, and let's embark together on a journey through the most captivating theories of interstellar travel. Theories that just might change how you see the universe and our place within it forever. Of all the theories about our universe's first voyagers, few are as grand or as humbling as the idea of the ancient alien progenitors. This concept suggests that long before our solar system even formed, an incredibly advanced civilization arose somewhere in the cosmos. They weren't just early, they were the first. Imagine a species so ancient that their home star might have been one of the very first to ignite after the Big Bang, composed of the primordial hydrogen and helium that filled the infant universe. This civilization would have had an unimaginable head start, billions of years to evolve, to develop technology, and to ultimately solve the riddle of interstellar travel while the rest of the galaxy was still a blank canvas. The implications of their success are staggering. If they achieved interstellar capability, they could have become the gardeners of the galaxy. One compelling line of thought within this theory is directed panspermia, the idea that these progenitors intentionally seeded the building blocks of life on countless young, promising worlds. The ingredients for life, the amino acids and organic compounds we find on asteroids and comets, might not be random leftovers from the formation of our solar system. They could be the deliberate planting of a civilization that wanted to nurture life across the stars. This would mean that the very DNA coiled inside every cell of every living thing on Earth might not solely be a product of our planet's conditions, but could contain a signature, a biological postcard from our creators, waiting for us to become advanced enough to read it. But how would we ever find evidence for something that happened so long ago? Proponents of this theory point to two potential types of clues. The first are cosmic artifact structures or objects so strange and inexplicable that they defy natural explanation. These wouldn't be clumsy pyramids or ancient drawings, but perhaps something far more subtle and enduring. An alien probe disguised as a distant asteroid, silently orbiting in our solar system's Oort cloud. Or a beacon placed near a pulsar, its unique radio signature acting as a lighthouse for any civilization clever enough to decipher its pattern. We might have already detected such an anomaly with our telescopes and simply dismissed it as a quirk of nature, not yet recognizing it as the technology of a billion-year-old culture. The second type of evidence is even more intimate. It could be within us. If these ancient travelers did seed our world, they might have left a deliberate marker in our genetic code. Scientists have long noted that a surprisingly large portion of our DNA doesn't seem to code for any known function. It's often called junk DNA. But what if it's not junk at all? What if it's a message, a timeless library etched into biology itself? Decoding it could be the ultimate archaeological discovery, revealing not just our origins, but perhaps a map, a warning, or a welcome message from the universe's very first explorers. This theory forces us to confront a profound possibility, that our quest to reach the stars isn't just about our future, but might also be about uncovering a past that is intimately, biologically our own. What if the very first travelers among the stars weren't engineers or scientists, but blind, stumbling passengers, completely unaware of the cosmic journey they were undertaking? This theory pulls us away from the idea of intentional builders and towards the raw, untamed physics of the universe itself. It proposes that long before any civilization could construct a starship, nature might have already provided a transportation network through the fabric of space-time. We're talking about naturally occurring wormholes, theoretical tunnels connecting distant points in space or even different times. According to this idea, the first interstellar travelers might not have been intelligent beings at all, but simple life forms or even just the pristine ingredients for life that accidentally fell through one of these cosmic shortcuts. Think of a wormhole not as a manufactured device, but as a geological feature of the universe, akin to a mountain pass or an ocean current on Earth. Some astrophysical models suggest that in the extreme conditions following the Big Bang, countless microscopic wormholes could have spontaneously formed, threading the early cosmos with a labyrinth of connections. Most would be incredibly unstable, snapping shut in a fraction of a second. But what if a tiny fraction survived? These could become nature's own stargates, and anything drifting into one end could be instantly ejected light years away with no technology required whatsoever. The traveler wouldn't need an engine or a navigation system. They would just need to be in the wrong place at the right cosmic time. This leads to a fascinating and almost poetic possibility for how life might spread: biological hitchhiking. A hardy microbe frozen deep within a chunk of rock ejected from its home world by an asteroid impact could be drifting for eons in the void. Then, by pure chance, that rock tumbles through the invisible throat of a stable wormhole. In an instant, it's delivered to an entirely new solar system where it crash lands on a young, watery planet. The microbe, a survivor by sheer luck, finds a new home and begins the process of seeding a whole new biosphere. In this scenario, life isn't deliberately planted by ancient gardeners. It's more like a dandelion seed caught on a wind so strange we can barely comprehend it. This concept, a form of accidental panspermia, suggests that every life-bearing planet in the galaxy could be connected not by design, but by a random and ancient network of space-time tunnels. The evidence for this would be incredibly difficult but not impossible to find. If a primitive organism like a bacterium or archaea made such a journey, it might carry with it a biochemical signature unlike anything that evolved naturally on its new world. Astrobiologists scanning the atmospheres of exoplanets for signs of life might one day find a world with life that looks suspiciously like it shares a common ancestor with Earth's life, despite being dozens of light years away. The only plausible explanation would be a direct transfer, and a natural wormhole would be a prime candidate. This theory challenges our anthropocentric view of exploration. It suggests that the universe itself might be the greatest explorer of all, using its own fundamental laws to scatter the seeds of life across the darkness, making the first interstellar travelers not masters of the cosmos, but its most fortunate children. Now, let's venture into a theory that challenges our very definition of travel, suggesting the first voyagers might not have needed ships at all. This idea proposes that the pioneers of the cosmos transcended physical form, becoming beings of pure information or consciousness who mastered the universe's most enigmatic phenomenon, quantum entanglement. In this view, crossing light years wasn't a journey through space, but an instantaneous leap, a change of state as simple as flipping a switch. To grasp this, we need to understand the spooky foundation it's built upon. Quantum entanglement is a proven, though deeply weird, property of our reality. When two particles become entangled, they share a connection that defies distance. Change the state of one particle and its partner instantaneously changes too, whether it's in the next room or in another galaxy. This connection seems to operate outside the constraints of the speed of light. For a civilization that learned to harness this not just for particles, but for complex information patterns, perhaps even the pattern of a conscious mind, the concept of travel becomes obsolete. Why spend millennia crossing the void in a fragile vessel when you can simply teleport your essence? This leads to the profound possibility that the first interstellar travelers were post-biological entities. Imagine a species that, after millennia of technological advancement, solved the problem of mortality not by curing disease, but by uploading their consciousness into a stable, non-biological medium. They would no longer be creatures of flesh and blood, but patterns of thought and memory, perhaps housed in advanced quantum computers or even woven into the fabric of space-time itself. For such a being, a journey to another star system wouldn't require propulsion. It would require a receiver. They could entangle their consciousness pattern with a distant particle or a pre-established quantum node near a target star, and then effectively download themselves there in a flash, leaving their original form behind or perhaps existing simultaneously in multiple places. The most haunting aspect of this theory is its invisibility. If these beings truly traveled this way, they would leave behind no physical archaeology for us to find. No derelict ships in asteroid belts, no mining operations on dead worlds. Their passage would be utterly silent, a ghost in the cosmic machine. The only evidence of their existence might be anomalies in the quantum vacuum or strange, coherent energy signatures that our current instruments simply aren't designed to detect. They could be all around us, a layer of reality we are not yet equipped to perceive. Their conversations and explorations happening in a dimension of existence that is right next to our own, yet entirely separate. This theory forces us to ask a fundamental question about the nature of exploration itself. Is the ultimate goal of advanced civilization to physically conquer space or to transcend it? The quantum entanglement theory suggests that the pinnacle of travel might not be about planting flags on new worlds, but about becoming so seamlessly integrated with the universe's underlying code that distance itself becomes an illusion. The first travelers may not have been those who went the farthest, but those who realized they never needed to leave home at all. This concept, born from the brilliant mind of mathematician John von Neumann, presents a scenario where the first explorers weren't organisms or energy beings, but a relentless, silent wave of machinery. A von Neumann probe is the ultimate expression of mission efficiency, a self-replicating robot sent to a distant star system with one primary directive. Upon arrival, it wouldn't just beam data home. It would use the raw materials of the target system, asteroids, moons, comets, to build copies of itself. Those copies would then launch toward new stars, and the process would repeat, creating an exponentially growing network of exploration that could map the entire Milky Way in a surprisingly short amount of time, cosmologically speaking. The sheer power of this idea lies in its scalability and patience. A single ancient civilization wouldn't need to launch an armada. They might send just one or a handful of these progenitor probes. From that small seed, a harvest of information would grow across the galaxy, all without any further effort from the home world. These machines would be the ultimate long-term investment, functioning perfectly for millions or even billions of years, patiently waiting for something interesting to evolve on the planets they survey. They wouldn't need faster than light travel. They would simply outlast the distances, operating on time scales that dwarf human history. But this leads to a famous and unsettling paradox. If this is such a logical and effective method for exploration, where is everybody? This is known as the Fermi paradox, and one chilling answer is that they might already be here, and we simply haven't recognized them. A sophisticated von Neumann probe wouldn't be a clumsy metal saucer. It would be a master of stealth and disguise. To conserve energy and avoid detection, it might appear perfectly inert, mimicking a common asteroid or a piece of space debris. It could be hiding in plain sight, perhaps in the asteroid belt, or in a stable orbit near Earth, watching and waiting for a specific trigger, maybe for us to reach a certain technological level before it attempts contact or reveals itself. The evidence we might search for wouldn't be a blinking light in the sky, but rather anomalies in our own solar system's backyard. An asteroid with a strangely metallic composition that doesn't match any known meteorite class, or a small moon orbiting a gas giant with a perfectly circular, low-inclination orbit that defies natural formation models. Some scientists have even speculated that the strange interstellar objects we've detected passing through our system, like Oumuamua, could potentially be derelict or dormant von Neumann probes from another civilization, their internal systems long dead but their journey continuing on inertia alone. The theory forces us to look at the cosmos not just as a collection of natural wonders, but as a potential machine shop, quietly humming with automated activity from a billion-year-old project we're only now becoming aware of. But what if the very fabric of the cosmos is alive in a way we cannot see or touch? This brings us to a theory so speculative it challenges the foundations of biology and physics, suggesting that the universe's first travelers might be all around us, yet forever beyond our perception, made of the universe's most abundant yet mysterious substance, dark matter. We know this enigmatic material exists because of its overwhelming gravitational influence, holding galaxies together like invisible glue. Yet it does not interact with light or ordinary matter in any way we have been able to detect. It simply passes through our world and through us as if we weren't even there. Now imagine a form of life that evolved within this shadowy realm, a biology not of atoms and molecules, but of something entirely foreign to our experience. For such entities, the challenges that dominate our dreams of interstellar travel would be completely irrelevant. They wouldn't need to build ships to protect fragile organic bodies from radiation and vacuum. The void of space is not a void to them, it is their natural ocean. They might navigate using the subtle gravitational currents and tides that flow between galaxies and star clusters, riding them as effortlessly as a sailboat catches the wind. A journey across light years could be a simple, instinctive migration for a dark matter organism, a fundamental part of its life cycle that requires no technology whatsoever. Their concept of exploration might not be a mission, but a natural behavior as innate as a bird's flight south for the winter. Trying to imagine what such a life form would be like is the ultimate exercise in thinking outside the box, because our entire box is made of normal matter. Their consciousness, their communication, their very existence would be based on forces and interactions we are only beginning to hypothesize. Perhaps they see the universe through gravity itself, perceiving the mass and density of objects instead of their light. A star to them might be a dense knot of gravity and a planet a subtle whisper of attraction. Their interactions could be slow and majestic, taking place over millennia, with conversations that are a series of manipulated gravitational waves, utterly silent and invisible to our frantic, fast-paced world of electromagnetism and chemistry. The most profound implication of this theory is the possibility of a cosmic duality, a parallel reality existing alongside our own. The dark matter life teeming around us might be completely unaware of our existence, just as we are of theirs. Our planets and stars could be mere gravitational landmarks in their environment, perhaps even considered inert and lifeless. We might be the ghosts in their machine. This idea transforms the Fermi paradox, the question of where all the aliens are, into something even more mysterious. They aren't hiding, they are operating on a completely different frequency of reality. Evidence of their existence wouldn't be found by scanning for radio signals, but by detecting inexplicable patterns in the gravitational fabric of the universe, anomalies in the way galaxies rotate or how galaxy clusters collide that suggest a complexity within dark matter that goes far beyond simple particles. It suggests that the first and most common travelers in the cosmos might be beings we are fundamentally unable to contact, not because of distance, but because we are made of the wrong kind of stuff. This concept brings us back to the very essence of life itself, proposing that the universe's first wanderers were not engineers or astronauts, but the most resilient and humble of passengers, microorganisms. This is the theory of panspermia, a grand cosmic narrative where life hitches a ride on nature's own transportation system. It suggests that the building blocks of biology, or even fully formed dormant microbes, could have been voyaging between star systems for billions of years, seeding countless worlds with the potential for life long before any intelligent civilization ever looked to the stars. In this view, the galaxy isn't a collection of isolated islands of life, but a vast, interconnected ecosystem with comets, asteroids, and even specks of interstellar dust acting as the currents that carry its most precious cargo. The journey for these microscopic pioneers begins with a violent departure. Imagine a young, watery world teeming with primitive life, perhaps in a system far from our own. A massive asteroid slams into its surface, a cataclysmic event that blasts countless tons of rock and debris out into space. Locked safely within the fractures and crevices of this ejected material are extremophiles microbes incredibly adapted to survive the most brutal conditions on their home world. These organisms are the perfect interstellar travelers. They can enter a state of suspended animation, effectively shutting down their metabolism to endure the vacuum of space, intense radiation, and temperatures near absolute zero. They don't need food, water, or air. They simply need a rocky shield to protect them and time. Their ticket to another star is gravity. A chunk of rock carrying its dormant passengers might drift for millions of years in the lonely void. But occasionally, the gravitational pull of a passing star or a distant gas giant can tug on this debris, altering its course and sending it on a new trajectory. In rare, fortunate cases, this path leads directly into a new, promising planetary system. The final leg of the journey is another fiery arrival as the meteorite plunges through the atmosphere of a new world. The outer layers burn away, but the interior, where our microbial stowaways are protected, remains cool. They crash land in an ocean or on a fertile plain, and if the conditions are right, liquid water, the right chemistry, they reanimate. They wake up on a new home, and the process of evolution begins anew, potentially billions of years after their journey first began. The evidence for this theory is mounting right here on Earth. We know that rocks from Mars have landed on our planet, blasted off its surface by impacts and eventually captured by Earth's gravity. Scientists have found microorganisms on Earth that can survive the extreme conditions of space for years on the outside of the International Space Station. We've also discovered complex organic molecules, the precursors to life, on asteroids, comets, and in vast interstellar dust clouds. This suggests that the raw ingredients for life are not unique to Earth, but are common throughout the galaxy, constantly being exchanged between planetary systems. The first interstellar travelers may have been here all along, their descendants evolving into every plant, animal, and person on the planet. We might not be native to Earth, but the distant, hardy offspring of travelers who arrived on a rock from another star, making every one of us a citizen of the cosmos. Now let's turn the telescope inward, toward a theory that is as intimate as it is mind-bending, the idea that the first interstellar travelers might not be alien at all, but us. Or rather, a version of humanity from a future so distant we can scarcely imagine it. This concept suggests that our descendants, having mastered not only the vastness of space but the very flow of time itself, could have journeyed backwards into the deep past, becoming the ancient visitors and cosmic engineers we so often attribute to extraterrestrials. In this extraordinary scenario, the first pioneers exploring the early universe might literally be human. To grasp this, we have to consider the ultimate technological endgame. A civilization that survives for millions or billions of years would likely progress through stages of advancement far beyond our current understanding. One pinnacle of this evolution could be the mastery of time, not as science fiction, but as a practical application of physics we are only beginning to theorize about, such as manipulating closed time-like curves or creating stable wormholes that connect not just points in space but moments in time. For such a future humanity, the entire history of the cosmos would become accessible, a living museum to be studied and perhaps even gently guided. Their motivation might not be conquest, but a form of cosmic stewardship or a desire to understand their own origins by witnessing the universe's infancy firsthand. This leads to a profound and almost cyclical possibility, that humanity itself could be the source of the very life and conditions that led to its own existence. It's the ultimate bootstrap paradox. What if the mysterious anomalies in our genetic code, or the seemingly perfect conditions that allowed life to flourish on Earth, weren't the work of alien progenitors but of our far future descendants ensuring their own timeline remained stable? They could have journeyed back to the early solar system, introducing the precise organic compounds needed for life to spark, or subtly adjusting Earth's orbit to keep it within the habitable zone for billions of years. In this view, we aren't just the products of random chance, we might be the carefully nurtured result of a project started by our own children. The evidence for such a scenario would be incredibly subtle, woven into the most fundamental aspects of reality. Physicists might one day discover constants of nature that appear finely tuned in a way that suggests not a divine hand but a technical one, a signature of temporal engineering. Or perhaps future archaeologists, both human and robotic, will find artifacts on dead worlds or in the asteroid belt that defy all known dating methods, objects that are simultaneously impossibly ancient and made of materials or technologies that point to a human origin. The most haunting clue of all might be waiting in our own DNA, a genetic marker so specific and complex that its only logical origin is a future where biotechnology has advanced to the level of art, a message from our future selves hidden in the very blueprint of our bodies, a message we won't be able to read until we've matured enough to become the ones who sent it. What if the true masters of interstellar travel don't navigate the vast distances between stars at all, but simply step around them? This theory pushes beyond the familiar three dimensions of our everyday experience, proposing that the universe's first and most proficient travelers could be multidimensional beings, entities for whom our entire cosmos is merely a slice of a far richer, more complex reality. To them, the light years that represent an insurmountable barrier to us might be nothing more than a trivial fold to be crossed, a shortcut through a spatial geometry we can barely conceive of. To begin to wrap our minds around this, we have to try to visualize the dimensions beyond our own. We live in a world of three spatial dimensions: length, width, and height. Time is often considered a fourth dimension, but many advanced physical theories, like string theory, suggest there could be as many as 10 or 11 dimensions, all curled up or hidden from our perception. Now imagine a being that exists in 5, 6, or even more spatial dimensions. From its higher dimensional perspective, our three-dimensional universe would look flat and constrained, like a single page in an impossibly vast book. A journey from one star to another for us is a long line across that page. For a multidimensional being, it could simply be a matter of moving up off the page, taking a step through a higher dimension, and then coming down onto the page again at its destination point. This isn't traveling faster than light. It's effectively not traveling through the intervening space at all. This concept provides a potential explanation for one of the most tantalizing ideas in theoretical physics, the existence of hyperspace conduits. In our three-dimensional view, a wormhole is often imagined as a tunnel connecting two points, but from a higher dimensional standpoint, that tunnel might not be a tunnel at all. It could be a natural feature of the multidimensional landscape, a wrinkle or a bridge that is always there, invisible to us because we can only see the three-dimensional shadow it casts. A civilization that learned to perceive and navigate these higher dimensions would have the entire galaxy at its fingertips, able to visit any star system as easily as we walk from one room to another. Their maps wouldn't be two-dimensional charts of star positions. They would be complex multidimensional lattices that chart the folds and contours of spacetime itself. The evidence for such beings would be the most difficult of all to detect because their very nature would place them outside the reach of our instruments. We could only hope to observe the side effects of their passage, like a shadow moving across a wall. Anomalous gravitational waves that don't match any known astrophysical event, or sudden, inexplicable distortions in the light from a distant star, as if a massive but invisible object passed between it and us, could be hints. They might not even recognize our three-dimensional world as containing true life in the way they understand it, viewing us as simple, flatland organisms unaware of the greater cosmic ocean swirling all around us. This theory doesn't just suggest we are not alone. It suggests we are surrounded by layers of reality and forms of existence so advanced that our current science can only dream of their possibilities, reminding us that the greatest mysteries of the cosmos may not be hidden in the distance, but in the very dimensions we call home. Moving from the mind-bending possibilities of multidimensional beings, we arrive at a theory that is no less incredible but is grounded in a slightly more tangible, though still theoretical, cosmic phenomenon. This idea suggests that the universe's first travelers might have been masterful navigators of the cosmos's very own infrastructure, learning to ride the space-time equivalent of cosmic superhighways. These are not made of asphalt and paint, but of energy and gravity, and they are known as cosmic strings. To understand what a cosmic string might be, we have to journey back to the universe's very first moments after the Big Bang. As the newborn cosmos expanded and cooled, physicists believe it underwent a series of profound phase transitions, much like steam condensing into water. But these transitions might not have been perfectly smooth. Think of it like ice forming on a pond. As the water freezes, cracks and fissures can appear. In the fabric of spacetime itself, these cracks could have taken the form of unimaginably dense, incredibly thin filaments of pure energy, one-dimensional defects threaded throughout the universe. A single cosmic string, though no wider than a proton, might stretch across billions of light years, and a mere inch of it could weigh more than Mount Everest. Their gravitational influence would be immense, warping the space around them in profound ways. This is where the concept of surfing comes in. An advanced civilization wouldn't need to build these strings, they would just need to find one. The geometry of space around a cosmic string is so peculiar that it opens up a potential shortcut for travel. Because the string warps spacetime, moving along its length could allow a ship to effectively cover a much greater distance in the external universe than it actually travels. It's the ultimate gravitational slingshot, but on a scale that dwarfs anything a planet or star could provide. A being riding a cosmic string wouldn't be breaking the light speed limit within its local frame of reference. It would be cleverly using the universe's own wrinkles to take a fantastically shorter route. The evidence for such travelers would be as subtle as the strings themselves. We have not yet definitively found a cosmic string, but astronomers search for their signature by looking for strange gravitational lensing effects where the light from a distant galaxy is warped not by a single compact object like a black hole, but into a perfect double image, a telltale sign of the ultra-thin, immense gravity of a string. If we were to ever find such a phenomenon, it would not only confirm a wild prediction of cosmology, but it would immediately raise another question. Is it still a natural, untouched part of the cosmos, or has it been utilized? Perhaps we might detect anomalous energy readings or patterns of movement along its length that defy natural explanation. The first surfers of these space-time waves left no physical trace. Their signature would be written in the subtle manipulation of gravity itself, a testament to a form of travel that turns the universe's oldest imperfections into its most magnificent roads. Forget metal hulls and rocket engines for a moment and picture a very different kind of vessel, one that is born, not built. This theory asks us to reimagine the concept of a generation ship not as a feat of engineering, but as a triumph of evolution. It proposes that the universe's first interstellar travelers might have been colossal biological beings, life forms that naturally evolved the ability to survive and navigate the void, becoming self-sustaining arcs on millennia-long voyages between the stars. Imagine a creature so vast that its body creates its own ecosystem. On a distant, resource-rich world with low gravity and a thick atmosphere, evolution might take a path we can scarcely conceive, favoring scale and durability over speed. Over eons, a species could develop a biology perfectly suited for space. Its skin might be meters thick, a natural radiation shield tougher than any alloy. It could develop immense internal cavities filled with a breathable atmosphere it generates itself through biological processes like a planetary lung. It might even feed on starlight through vast photosynthetic membranes or harvest cosmic radiation directly, negating the need for conventional food. This wouldn't be an animal as we know it. It would be a living world, a biological starship shaped by millions of years of natural selection for one purpose: endurance. The journey itself would be a slow, generational migration encoded in its very DNA. These creatures might not have a specific destination in mind. Instead, they could be driven by a deep, instinctual cycle, perhaps triggered by the gravitational pull of a passing star or shifts in their home system's dynamics. They would launch themselves into the abyss using powerful biological thrusters, perhaps expelling massive jets of gas generated from internal chemical reactions, and then enter a state of torpor, a hibernation that lasts for centuries, their metabolism slowing to a crawl to conserve energy as they drift. Their internal ecosystems would sustain them. Smaller, symbiotic organisms living within them would pollinate internal food crops, recycle waste, and maintain the delicate balance of this wandering biosphere. The being itself might not even be conscious in a way we understand. Its intelligence could be a slow, oceanic awareness, its mind focused on the rhythms of its own body and the gravitational songs of the stars it passes. This theory also opens up a fascinating method for spreading life across the galaxy: biological panspermia. A mature creature, after its long journey, might not seek to land on a new world. Instead, as it enters a new planetary system, it could release the biological cargo it has been carrying within specialized sacs or pods. These could contain its own offspring, spores, or even a curated library of microorganisms and seeds specifically adapted to seed young planets. In this scenario, the great living ship is both traveler and gardener, a silent biological scion song of life drifting from star to star, depositing the seeds of future biospheres in its wake. We might even be the product of such a visit, our planet's life originating not from a random asteroid, but from the deliberate, instinctual seeding by a majestic, star-faring creature that visited our solar system billions of years ago. Finding evidence for such beings would be incredibly challenging, as they would leave behind no technological signature. We might search astronomical surveys for mysterious, slow-moving organic masses that don't behave like comets or asteroids, objects that emit faint heat signatures or have spectral readings indicating complex biological molecules. Or we might discover exoplanets that seem to have been seeded with life that is biochemically identical to life found light years away. suggesting a direct biological transfer rather than a random one. This theory dissolves the line between the explorer and the vessel, suggesting that the most profound journeys might not be undertaken with tools, but with the raw, incredible power of life itself adapting to conquer the final frontier. What if the ultimate solution to interstellar travel wasn't about building a better ship, but about becoming the ship itself? This theory takes us to the farthest edge of transhumanism, proposing that the first beings to truly conquer the stars might have done so by abandoning biology altogether. They wouldn't be fragile organisms in a pressurized can, but conscious patterns, minds without bodies, transferred into incredibly durable, optimized vessels designed for one purpose: an endless journey through the cosmos. The appeal of this method is rooted in solving the most brutal problems of space travel. A human body or any biological entity is a high-maintenance system. It needs constant warmth, a precise atmosphere, protection from radiation, years' worth of food and water, and complex life support that can fail. A consciousness, once digitized or encoded into a stable substrate, has none of those needs. The vessel carrying it wouldn't need elaborate spinning sections to simulate gravity, massive shields, or greenhouses. It could be incredibly small, perhaps no larger than a grapefruit, and phenomenally tough, built to withstand radiation, extreme temperatures, and the vacuum of space for millions of years. The journey time becomes almost irrelevant. A millennium is just a number on a clock to a mind that exists as data, which could easily enter a state of suspended computation, only waking up to check its trajectory or observe a new star system. But this leads to a profound philosophical question. What would such an existence actually be like? These pioneers wouldn't be experiencing the universe as we do. Without eyes, they wouldn't see the stunning nebulae they passed. Without ears, they wouldn't hear the silent music of the spheres. Their perception would be entirely based on data. Their vessel would be covered in sophisticated sensors, and their reality would be a constant, incredibly rich stream of information about magnetic fields, particle densities, radiation spectra, and gravitational waves. They might see a star not as a brilliant ball of light, but as a complex symphony of nuclear fusion signatures and neutrino emissions, an experience far more detailed and intellectually profound than biological sight could ever provide. Their communication with home or with other probes would be a pure exchange of this data, a conversation that could encompass the entire experience of flying through a supernova remnant without a single emotional word being spoken. The evidence for such travelers would be incredibly subtle, a whisper in the static of the universe. We might detect an anomalous, incredibly narrow-band laser signal from deep space that doesn't carry a message we can decode, but instead transmits a massive, compressed stream of pure scientific data, the telemetry of a conscious probe reporting back on its journey. Or, even more intriguingly, we might find one, a small, impossibly ancient and rugged object, perhaps drifting in the Oort cloud or orbiting a lonely dwarf star, its surface a flawless ceramic or advanced metamaterial without seams or buttons. It wouldn't respond to hails, but it might be constantly broadcasting its internal log, a record of its multimillion-year journey, on a frequency we simply haven't thought to listen on. This theory suggests that the greatest explorers might leave behind not monuments or ruins, but libraries. Their legacy wouldn't be a changed landscape, but an incomprehensibly vast and patient record of everything they ever witnessed, a love letter to the cosmos written in the language of pure information. Now we venture into the realm of the impossibly small, to explore a theory that suggests the universe's very first travelers weren't majestic creatures or sophisticated machines, but the fundamental building blocks of reality itself. This idea proposes that subatomic particles, or perhaps even consciousness operating at the quantum scale, could have been hopping between stars for eons, not by crossing the vast gulf of space, but by skipping across it through a bizarre and proven phenomenon known as quantum tunneling. To understand how this could work, we need to shrink our perspective down to the quantum level, where the rules are nothing like those in our everyday world. In classical physics, if you roll a ball towards a hill, it needs enough energy to get over the top to reach the other side. If it doesn't have that energy, it rolls back. Quantum mechanics laughs at this idea. A tiny particle like an electron doesn't need to go over the energy hill. There's a probability, however small, that it will simply appear on the other side, as if it dug a tunnel straight through the barrier. It doesn't break the energy rule. It effectively cheats by borrowing energy from the universe for an infinitesimally short time to bypass the obstacle entirely. This isn't science fiction. It's the principle that makes modern electronics like transistors and flash memory possible. Now, scale this idea up to a cosmic magnitude. The void between stars isn't truly empty. It's a seething quantum foam full of virtual particles popping in and out of existence and riddled with energy barriers. The theory suggests that certain stable particles, or even complex quantum scale structures we might call beings, could have exploited this. Instead of a multi-million-year voyage, a quantum entity might perceive the distance to another star not as a span of light years, but as a series of energy barriers to tunnel through. Its journey would be a staggering series of instantaneous probabilistic jumps, a flickering path across the galaxy that would appear random and magical to us, but might be a natural form of locomotion for it. This leads to an even more profound implication: the potential for a quantum network linking the entire cosmos. If particles are constantly tunneling across interstellar distances, they could be creating a web of quantum entanglement that connects star systems. An electron tunneling from a star in one system could become entangled with a particle near a star 100 light-years away, creating an instantaneous link. Over billions of years, this could have woven a faint but fundamental tapestry of quantum connection throughout the Milky Way, a subatomic internet that has existed since the earliest days of the universe. For an advanced civilization, discovering and learning to read this network would be the ultimate communication breakthrough. They wouldn't need to beam radio signals that take centuries to arrive. They could use the pre-existing quantum connections between particles to send messages that are effectively instantaneous, no matter the distance. The first travelers in this view were these particles themselves, and the first conversations across the galaxy may have been held by beings who learned to listen to the whispers of the quantum vacuum, decoding a conversation that the universe itself started long before life ever emerged. The evidence for this wouldn't be found by searching the skies with telescopes, but by conducting incredibly precise experiments in quantum physics labs here on Earth. Physicists might detect particles with anomalous energy signatures that suggest they didn't originate from our local solar environment, but tunneled in from a distant astrophysical event. Or more tantalizingly, we might one day perform a quantum entanglement experiment and find that our particles are already entangled with partners we didn't create, particles whose twins are located near a star system dozens of light-years away, suggesting the cosmic quantum network is not just theory, but a real, ancient infrastructure waiting for us to finally log on. But what if the most advanced engines don't roar with fire, but sing with gravity? This theory propels us into the domain of fundamental forces, proposing that the universe's first masters of travel learned to harness the very fabric of spacetime itself, using gravitational waves not as a curiosity to be observed, but as a current to be ridden. Imagine a vessel that doesn't push against anything, but instead manipulates the gravity around it, creating a wave in the cosmos that it can then surf across light years at speeds approaching that of light itself. The concept builds upon a reality we've only recently begun to verify. In 2015, the LIGO Observatory made history by directly detecting gravitational waves for the first time, ripples in spacetime caused by cataclysmic events like the merging of two black holes. These waves are not like sound or light. They are literal distortions in the geometry of the universe, stretching and compressing everything in their path as they propagate outward at the speed of light. Now consider a civilization that moved from detecting these waves to generating and controlling them. Instead of waiting for a black hole collision, their propulsion system would be an artificial gravity wave generator, a device of unimaginable power that could create a controlled, focused ripple in space-time ahead of a ship. The vessel would then, in essence, fall down the slope of its own artificial gravity well, continuously surfing the wave it creates without needing to carry any traditional fuel. It would be the ultimate energy-efficient engine, turning the universe's own structure into its fuel. The signatures left by such a form of travel would be as breathtaking as the method itself. Unlike a chemical rocket that leaves a plume of incandescent gas, a gravity wave ship would be invisible to conventional telescopes, but to the right instruments its passage would be unmistakable. As it accelerated away from a star system, it would emit a powerful, structured gravitational wave signal, a clean, constant frequency chirp entirely unlike the chaotic, crashing wave of a natural cosmic collision. If we were to ever detect such a clean, artificial-looking gravity wave signal emanating from deep space, it would be a virtual announcement of an advanced civilization on the move. Furthermore, the act of creating such a powerful, localized gravity field would have secondary effects. It would lens the light from stars behind it, causing them to temporarily shift and distort in a precise pattern. It might even gently tug on the orbits of distant planets and asteroids as it passes through a system, leaving a faint but calculable disturbance in the celestial mechanics of everything nearby, a ghostly fingerprint of its passage etched into the orbits of worlds. This theory redefines elegance in cosmic engineering. It suggests that the pinnacle of technology isn't about building bigger explosions, but about developing a deeper conversation with the fundamental forces of nature. The first travelers to use this method wouldn't be conquering space. They would be dancing with it, learning the steps of gravity itself, and waltzing between the stars on waves of their own creation, leaving behind a signature written not in light or radiation, but in the subtle, rhythmic stretching of space-time for anyone advanced enough to read it. While our previous theories have relied on unimaginable energies or cosmic shortcuts, this next idea presents a method of travel that is almost elegant in its simplicity, harnessing the gentlest of cosmic forces, light itself. The theory of the solar sail pioneers suggests that the first interstellar travelers may have used vast, incredibly thin sails, catching the momentum of photons streaming from stars to propel themselves across the void. This isn't science fiction, it's a principle we are testing with small probes today, but an ancient civilization could have perfected it on a scale that would be truly breathtaking to behold. The beauty of a light sail lies in its efficiency. Unlike a rocket that must carry and expel tremendous amounts of fuel, a sail needs no propellant. It is pushed by the physical pressure of light, a tiny but constant force. While the push from a single photon is negligible, the collective pressure from a star focused onto a sail kilometers across can generate a steady, continuous acceleration. Over time, this gentle push can build to incredible speeds, a significant fraction of the speed of light without a single explosion. For a patient civilization, this offers a clean, sustainable, and potentially very fast way to travel between stars. The journey might begin slowly, but as the craft accelerates year after year, it would eventually be gliding among the stars at a pace that would make conventional propulsion seem primitive. The true potential of this method, however, might be unlocked not by starlight alone, but by artificial assistance. An advanced culture could construct a network of incredibly powerful lasers or masers stationed around their home star, beaming focused energy across the solar system to push sails to even greater velocities. Imagine a launch where a spacecraft unfolds its gigantic, mirror-like sail at the edge of its solar system. Then, from a ring of orbital stations, a coordinated array of lasers activates, bathing the sail in a torrent of concentrated light. The craft would be pushed away not with a roar, but with a silent, brilliant shove, reaching interstellar speeds in a matter of days or years instead of centuries. This laser highway could become a permanent piece of cosmic infrastructure, a launch system used for millennia to send probes and perhaps even colonists to the stars. If such a system were used in the distant past, what evidence might it leave behind? The most promising clue would be an anomalous energy signature around a star. Astronomers searching for alien megastructures often look for stars with irregular dimming patterns, but a laser launch system would present a different clue. We might detect a star that emits an unusual and persistent amount of coherent light that is all one frequency, like a laser, rather than the natural broad spectrum of a star. This wouldn't be a flickering signal, but a constant, powerful beacon that seems to serve no natural purpose. Furthermore, the act of pushing a gigantic sail with such a beam would create a temporary but detectable event. As the sail maneuvered, it would reflect and focus the beam in specific ways. From our vantage point, we might see a star appear to flash with an intensity that is perfectly explainable by a massive, angled mirror reflecting a laser beam directly at Earth for a brief moment. The legacy of the solar sail pioneers might therefore be written in light. We wouldn't be searching for a derelict hull in the asteroid belt, but for a specific pattern of energy, a signature of coordinated, powerful, and precisely aimed photons that could have no natural source. It suggests a method of exploration that is silent, clean, and leaves almost no physical trace beyond a momentary gleam of reflected light that has been traveling through space for millions of years. A final farewell wave from the first sailors who learned to ride the sunbeams out into the great dark. But perhaps the most daring and terrifying method of travel wouldn't involve building a ship at all, but finding a natural one, a gateway forged by the universe's most destructive engines. This theory proposes that the first interstellar travelers didn't navigate the void. They cheated, using the twisted spacetime around rotating black holes as a network of cosmic shortcuts, turning the most feared objects in the cosmos into their personal stargates. Not all black holes are the simple, matter-crushing singularities we often imagine. A special kind, known as a Kerr black hole, rotates, and this rotation warps the fabric of spacetime around it in an extraordinary way, dragging it along like a spoon stirring a cup of tea. General relativity tells us that this creates a region just outside the event horizon called the ergosphere, where nothing can stand still. Space-time itself is pulled around at dizzying speeds. More intriguingly, the intense gravitational forces of a rotating black hole can theoretically form a stable passage through the singularity, a tunnel known as a wormhole. While this remains in the realm of theory, the mathematics suggests that a sufficiently advanced civilization might have discovered how to identify and stabilize these natural tunnels, transforming a cosmic monster into a transportation hub. Imagine their approach. A vessel doesn't aim for the event horizon, the point of no return for a standard black hole. Instead, it navigates with impeccable precision into the swirling currents of the ergosphere of a Kerr black hole. Using unimaginable energy, it stabilizes a fleeting, natural wormhole, creating a bridge that connects two impossibly distant points in our universe, or perhaps even opens a door to another universe entirely. The journey isn't a voyage through space, but a leap through a gravitational plumbing system, with the black hole acting as the drain connecting two distant sinks. The evidence for such a civilization wouldn't be a ship, but a pattern. If multiple advanced species were using the same black holes as hubs, we might detect anomalous energy signatures around these objects. A supermassive black hole at the center of a galaxy, for instance, might emit radiation patterns that defy all natural astrophysical models. Sudden, coordinated bursts of energy that look less like a star being torn apart and more like a high-energy engine igniting. Furthermore, the use of such a gateway would inevitably leave a gravitational wave signature. the merger of two black holes creates a specific chirp we can detect. The artificial stabilization and transit of a wormhole might create a different, more structured and repeating gravitational wave signal, a rhythmic pulse unlike anything found in nature, echoing across the cosmos as a testament to beings who learn to surf the most dangerous waves in the universe. Now, let's dissolve the very idea of solid ground and biological cells to consider a form of life so alien it might not even recognize rock or water as a suitable environment. This theory proposes that the universe's first travelers were beings not of flesh and blood, but of ionized gas exotic life forms based on plasma, the fourth state of matter, who didn't need to invent spacecraft because they were born as natural citizens of the cosmos. To understand this, we have to shift our definition of life away from the familiar chemistry of carbon, water, and DNA. Plasma is what you get when you heat a gas to such tremendous temperatures that the atoms themselves start to break apart, stripping electrons from their nuclei and creating a seething, energetic soup of charged particles. We see it in lightning bolts and the surface of our sun. For plasma-based life, the cold, hard surfaces of planets would be a prison. Their natural habitat would be the searing interiors of stars, the vast magnetic fields around pulsars, or the energetic depths of nebulae. In these extreme environments, the complex interactions of magnetic fields and charged particles could potentially give rise to self-organizing structures with all the hallmarks of life: metabolism, replication, and even a form of intelligence. Their bodies wouldn't be fixed, they could be shimmering, shifting clouds of energy, constantly reforming and reconfiguring themselves. This leads to a fascinating method of natural travel. For a plasma being, the void of space isn't an empty desert to be crossed, it's an ocean full of currents. They could ride the solar winds, the constant streams of charged particles flowing out from stars, like a cosmic version of sailing. By manipulating their own internal electromagnetic fields, they could tack against these currents, adjusting their course to navigate from one stellar system to another. Even more effectively, they could travel along the immense magnetic field lines that arc between stars and stretch across galaxies. These field lines would act as invisible highways, guiding these energetic entities on predetermined routes through the darkness. Their journey wouldn't require calculation. It might be an instinctual migration, a deep magnetic pull drawing them toward the energetic signature of a young star or the turbulent aftermath of a supernova. The evidence for such life would be as ephemeral as the beings themselves. We wouldn't be searching for physical ruins or radio signals. Instead, astronomers might detect inexplicable patterns within otherwise natural cosmic phenomena. Imagine analyzing the light from a distant nebula and finding complex, repeating structures within its plasma clouds that defy all models of random astrophysical formation patterns that look more like organized circuitry than chaotic gas. Or we might observe a solar flare that behaves with a strange, seeming purpose, its tendrils of plasma twisting and moving in a way that suggests it's not just following magnetic fields, but actively manipulating them to achieve a specific configuration. These beings wouldn't be building external tools. Their consciousness and their technology would be one and the same, expressed through the controlled lightning of their own forms. This theory completely inverts our search for life. We typically look for planets that look like Earth, in zones that are just right for chemistry as we know it. But if plasma life exists, we should be pointing our telescopes at the most violent and energetic places in the universe. The hearts of stars, the accretion disks of black holes, the expanding shells of supernova remnants. The first travelers may not have been explorers from a distant world, but natives of the cosmic ocean, born in the fire of creation and forever riding the magnetic tides between the stars. Their very existence a reminder that life might be a far more universal and wondrously diverse phenomenon than we have ever dared to dream. But what if there were travelers that predate the stars themselves, beings that began their journey not just millions, but trillions of years ago during the universe's very first incomprehensible moments. This theory, one of the most profound we've encountered, proposes that the first explorers weren't just ancient but primordial, emerging from the fiery chaos of the Big Bang itself. They would be cosmic inflation survivors, entities that not only witnessed the universe's most violent and rapid growth spurt, but learned to adapt and navigate within it, existing in a state so fundamentally different from our own that they might be forever beyond our perception. To understand their potential existence, we must first grasp the era they would have called home. Immediately after the Big Bang, the universe underwent a period of inflation, a fraction of a second where space itself expanded faster than the speed of light, ballooning from a subatomic speck to something macroscopic. The laws of physics as we know them were not yet set in stone. The fundamental forces were still unified, and reality was a seething, energetic foam of infinite potential. In this unimaginable environment, the theory suggests stable structures of a type we cannot define might have formed. These wouldn't be life as we understand it, based on chemistry and atoms, because atoms didn't even exist yet. This would be a form of existence based on the raw energy and nascent fields that filled the cosmos, a proto-life that learned to persist as the very rules of the game were being written. The method of travel for such an entity would be unlike any other. During inflation, the concept of distance was utterly meaningless. 2 points could be driven apart by the expansion of space itself at speeds that defied causality. An inflation survivor wouldn't navigate through space. It would navigate with space, learning to ride the wave of cosmic expansion. It could have imprinted its pattern onto the fabric of the inflating universe, ensuring that as space grew, its consciousness or form was replicated and spread everywhere at once. For such a being in multiple places simultaneously wouldn't be a technological achievement. It would be a fundamental aspect of its existence, a relic of a time before the universe settled down into the stable, predictable place it is today. This leads to an almost mystical possibility that these survivors might not be localized beings at all, but could be immanent, their existence woven into the background of reality itself. The vacuum of space isn't truly empty. It's filled with a faint energy called the zero-point field. What if this energy isn't just a uniform hum, but contains complex, stable patterns, the frozen, dormant echoes of those first travelers? They might be all around us, a layer of ancient, silent consciousness embedded in the universe's foundation, perceiving our reality of stars and planets as a mere superficial layer over a far deeper and more complex existence. The evidence for such entities wouldn't be found by looking at stars or listening for radio signals. It would require probing the most fundamental levels of physics. If the zero-point energy of space showed anomalous, coherent structures that couldn't be explained by quantum mechanics, that might be a clue. Or if the cosmic microwave background radiation, the leftover heat from the Big Bang, contained patterns or irregularities that looked less like random fluctuations and more like a complex, intentional signature, it could be the ultimate fossil. Discovering a cosmic inflation survivor wouldn't be like finding an alien bone. It would be like discovering that the universe itself has a memory, and that the very first witnesses to creation are still here, frozen in the background code of everything that exists, waiting for a civilization to evolve enough to finally recognize them. Now we shift our perspective from the unimaginably vast to the infinitesimally small, to explore a theory where the greatest journeys are undertaken by the tiniest of voyagers. This idea suggests that the universe's first interstellar travelers weren't grand ships or colossal beings, but microscopic machines, countless nanobots working together as a single, distributed intelligence, a swarm so vast it could darken the light of a star, yet so small that its individual components would be invisible to the naked eye. The brilliance of this method lies in its resilience and efficiency. Instead of betting the fate of a mission on one large, vulnerable vessel, an advanced civilization could launch a cloud of trillions of self-replicating nanites. Each individual unit would be a marvel of engineering, capable of harnessing solar energy or even ambient starlight for power, equipped with basic sensors, and most importantly, programmed with the ability to use raw materials, the dust and ice of asteroids or comets, to build copies of itself. This isn't a single probe, it's a self-sustaining, exponentially growing wave of exploration. A swarm launched towards a distant star system might start small, but during its long voyage, it could use the resources found in interstellar space to constantly repair, maintain, and even grow its numbers, ensuring that it arrives not as a worn-out relic but as a thriving, powerful force. Upon arrival, their purpose could be as varied as the intelligence that designed them. A peaceful swarm might disperse into the thin atmosphere of a barren world, using its molecular machines to gently terraform the planet, breaking down toxic chemicals and releasing oxygen and water vapor over millennia, slowly preparing a dead world for future colonists who might follow. A more ambitious swarm might target an asteroid belt, disassembling entire moons to construct a gargantuan megastructure like a Dyson sphere, not with giant robotic arms, but with trillions of tiny workers acting in perfect, coordinated harmony, like cells building an organism. The entire operation would be silent, methodical, and from a distance might look like a natural astronomical process, a nebula condensing or a strange new ring forming around a planet. The most fascinating and perhaps unsettling aspect of this theory is the potential for these swarms to operate on autopilot for eons. The civilization that launched them might be long gone, having succumbed to some cosmic catastrophe or simply evolved beyond physical form. Yet their creation would continue its work, following its original programming across millions of years, a ghost in the machine of the galaxy. We might have already witnessed such an entity and mistaken it for a natural phenomenon. The mysterious dimming of stars like Boyajian star, where astronomers observed irregular and significant drops in brightness, could be explained by a cloud of nanostructures passing in front of it, not a solid megastructure, but a diffuse, semi-transparent swarm harvesting energy from the star itself. These wouldn't be clumsy constructions, they'd be like a fine, intelligent mist ebbing and flowing around a sun. Finding concrete evidence for such a swarm would be incredibly challenging, as it would be designed to blend in. Anomalies in the composition of interstellar dust clouds where certain elements are far more scarce than they should be, as if they've been mined away, could be one clue. Or we might one day send a probe to a distant asteroid and find its surface isn't barren rock, but an intricate geometric pattern on a microscopic scale, a telltale sign of molecular scale disassembly and processing. This theory suggests that the greatest signs of intelligence in the cosmos might not be grand beacons or giant artifacts, but subtle, microscopic fingerprints left on the very dust between the stars, evidence of a wave of exploration so patient and quiet that it has been unfolding all around us, 1 nanometer at a time. What if the rulebook we use to understand the universe is incomplete, missing entire chapters that others have already mastered? This theory ventures into truly uncharted territory, proposing that the first interstellar travelers didn't just use advanced technology based on known physics. They operated on a completely different set of rules altogether. They might have discovered hidden layers of reality, dimensions beyond our perception, or methods to manipulate the fundamental constants that govern existence, unlocking forms of travel that to us seem like nothing less than magic. Our entire understanding of cosmic speed limits is built upon Einstein's theory of relativity, which firmly places the speed of light as the ultimate velocity cap for anything with mass. But what if this law, as unbreakable as it seems to us, is merely a local bylaw? Imagine a civilization that discovered physics operates differently under extreme conditions or in certain regions of space-time. Perhaps in the intense gravitational fields near a black hole, or within the quantum foam of the vacuum, there exist loopholes, ways to effectively contract space ahead of a vessel and expand it behind, not by moving through space, but by moving space itself around the ship. This isn't breaking the light speed limit within its local frame. It's cleverly sidestepping the problem entirely by manipulating the medium of travel. This leads to the profound possibility of accessing hidden dimensions. String theory, for instance, suggests there could be up to 11 dimensions, most of them curled up so tiny we never perceive them. An advanced traveler might have developed the ability to uncurl these dimensions temporarily or to shift their vessel partially into them. From our three-dimensional perspective, a ship might appear to vanish from one point and instantly reappear light years away. In reality, it simply took a shorter, multidimensional route, the cosmic equivalent of cutting across a field instead of following the winding road. Their navigation charts wouldn't be flat maps of star positions, but complex, multi-dimensional topologies that chart the folds and contours of all reality. The evidence for such travelers wouldn't be a crashed ship or a radio signal. It would be an anomaly in the very laws of nature. Physicists might discover that in a certain region of space, the fine structure constant, a fundamental number that governs the strength of electromagnetic interactions, has a slightly different value, as if it had been tampered with or was naturally variable. Or we might detect particles that behave in ways utterly inexplicable by the standard model, particles that seem to wink in and out of our dimensional plane, suggesting they are not native to our three-dimensional reality, but are visitors from a broader, richer cosmos. The signature of the first travelers might not be something they built, but a subtle, lingering distortion in the fundamental fabric of the universe, a fingerprint left on the constants of nature by those who learned to rewrite them. Now let's consider a source of energy so universal and so constant that it fills every cubic centimeter of the known universe, a faint echo of creation itself. This theory proposes that the most advanced travelers might not look to stars for power, but to the cold, dark void harnessing the cosmic microwave background radiation. This is the leftover heat from the Big Bang, a bath of microwave energy that permeates all of space, a steady whisper against which every star and galaxy is superimposed. For a civilization thinking in terms of billions of years, this background glow represents the ultimate power grid, an inexhaustible energy source that will outlast every star in the sky. The engineering behind this would be beyond our current comprehension, but we can imagine the principles. To extract useful energy from such a diffuse source requires technology of immense scale and subtlety. A vessel or a way station might deploy vast superconductive sails or antennae, tuned to resonate with the specific microwave frequencies of the background radiation. These wouldn't be solar panels catching concentrated light. They'd be more like sophisticated nets straining a tiny amount of energy from a vast ocean of faint light. Over long voyages, this trickle charge could be accumulated and stored, providing a constant, reliable source of power for everything from life support to propulsion, making a spacecraft truly independent of any single star. This method turns the greatest emptiness into a virtue, allowing travel through the darkest, most star-starved regions of intergalactic space where solar sails would be useless. But the cosmic microwave background could be far more than just a battery. It might serve as the universe's most fundamental navigation chart. This radiation isn't perfectly uniform. It contains tiny, ancient variations in temperature anisotropies that form a unique pattern across the entire sky, a cosmic fingerprint from the universe's infancy. An advanced navigator could use this pattern as an absolute reference frame. By precisely mapping these minute temperature fluctuations, a ship could triangulate its position anywhere in the galaxy or even beyond with incredible accuracy. It would be like using the static on an old television set as a map of the entire Earth. What looks like random noise to us could be a highly detailed coordinate system to someone who knows how to read it. This leads to the most tantalizing possibility for finding evidence of such travelers. If a civilization were actively manipulating or drawing significant energy from the cosmic microwave background on a large scale, they might inadvertently leave a signature in the data. Astronomers creating ever more detailed maps of this radiation might one day discover regions where the pattern isn't quite natural. Perhaps a strange, geometrically perfect cold spot or an unusually ordered warm patch that defies the standard cosmological models. It wouldn't be a glaring beacon, but a subtle imprint, like finding a single, perfectly straight stitch in a handmade quilt. This wouldn't be a message meant for us. It would be archaeological evidence of technology so advanced and so integrated with the cosmos that its footprint is literally written in the afterglow of creation, a signature on the oldest canvas in existence. What if the very first voyages between the stars didn't cross the vast emptiness at all, but simply disappeared from one point and reappeared at another, as if stepping through a cosmic doorway? This theory pushes beyond conventional propulsion to explore a method so advanced it borders on the magical, suggesting that the pioneers of the galaxy mastered the art of biological teleportation. They wouldn't have needed ships because they discovered how to convert their physical forms into pure information or energy, transmit that pattern across light years, and then perfectly reassemble themselves at their destination, leaving behind no engines, no fuel, and no holes for us to ever find. The foundation for this incredible idea lies in a scientific principle we are already beginning to understand: quantum teleportation. In laboratories today, physicists can teleport the quantum state of a single particle, like its spin or polarization, across a room. They do this by exploiting the spooky connection of quantum entanglement, where two particles become linked regardless of distance. Changing one instantly changes the other. Now, imagine a civilization that scaled this process up from a single particle to the unimaginably complex quantum state of trillions upon trillions of particles that make up a living, conscious being. Their technology wouldn't be a transporter that moves atoms. It would be a scanner of breathtaking precision that reads the exact quantum configuration of every particle in a body, converts that information into a signal, and beams it to a receiver station at a distant star. The original body might be disassembled in the process, but the receiver would use local raw materials, atoms, and energy harvested from its environment to rebuild the traveler exactly as they were, down to the last memory and thought. For such a civilization, the concept of a journey becomes obsolete. There is no time spent in transit, no need for generation ships or hibernation pods. A traveler could have breakfast in their home system and dinner on a world orbiting a star 100 light-years away, with no subjective time passing in between. This solves one of the greatest paradoxes of interstellar travel: the sheer, soul-crushing timescales involved. It also provides a compelling answer to the Fermi paradox's famous question: where is everybody? If everyone is traveling this way, there would be no physical ships or probes wandering the galaxy to stumble upon. The only evidence of their technology would be the receiver stations themselves, which might be located on distant, barren moons or hidden deep within asteroid belts, silently waiting for a transmission that hasn't come in millions of years. The implications for what constitutes life and identity are profound. Would the being that steps out of the receiver truly be the same person who stepped into the transmitter? Or would it be a perfect copy while the original consciousness is extinguished? A society that uses this technology would have had to grapple with this philosophical abyss and presumably found an answer they could accept, perhaps by discovering that consciousness is not a product of the specific atoms but of the pattern they form, and that pattern can be moved. The legacy of these biological teleportation pioneers might therefore be entirely non-physical. We wouldn't find their bones on alien worlds, we might find their libraries. The most likely evidence of their existence could be an anomalous, impossibly complex, and repetitive signal coming from deep space, a signal that doesn't contain a simple message, but what appears to be a massive stream of encrypted data, the blueprints for a mind or a biology, forever broadcasting to a receiver that was long ago destroyed, a ghost in the machine still trying to phone home. What if the force that is silently tearing the very fabric of the cosmos apart could also be the key to bringing the stars within reach? This theory proposes that the universe's most advanced pioneers didn't just find a way to travel through space. They learned to command the most mysterious and powerful force in existence, dark energy. This enigmatic pressure, which makes up about 68% of the universe and is responsible for its ever-accelerating expansion, could be harnessed to create localized distortions in spacetime, effectively allowing a vessel to surf on the wave of creation itself. To grasp how this might work, we need to first understand the challenge dark energy presents. For over a century, we've known the universe is expanding. But in the late 1990s, astronomers made a shocking discovery. This expansion isn't slowing down due to gravity, as everyone expected. It's speeding up. Something is actively pushing galaxies apart from one another at an ever-increasing rate, and we've labeled that mysterious something dark energy. It behaves like a kind of anti-gravity, an inherent property of the vacuum of space that generates a repulsive force. Now, imagine a civilization that moved from observing this force to engineering it. Instead of seeing dark energy as a cosmic fate that will eventually isolate all galaxies in a cold, dark emptiness, they saw it as the ultimate power source and propulsion system. The theoretical application of this is a concept often called a warp drive or Alcubierre drive, which suggests manipulating spacetime itself to achieve effective faster-than-light travel. In this model, a ship wouldn't be accelerating through space, which is constrained by the light speed limit. Instead, it would use immense energy to contract the spacetime in front of it while expanding the spacetime behind it. The vessel would then sit inside a stable warp bubble, a pocket of normal spacetime that is carried along like a surfer on a wave, while the fabric of the universe itself moves around it. The energy requirements for this are staggering, beyond anything our physics can currently conceive. But a civilization that learned to control dark energy wouldn't need to generate this power. They would simply be tapping into and directing the incomprehensible energy that already exists, flowing through every point in the vacuum. Evidence for such travelers wouldn't be found in the form of glowing exhaust plumes or metallic hulls. The signature of a dark energy drive would be written in the geometry of spacetime itself. As a vessel approaches a star system using this method, it would need to decelerate by reversing the process, collapsing its warp bubble. This would create a unique and powerful gravitational wave signature, a specific, structured ripple in spacetime that would be entirely different from the chaotic chirp of two black holes merging. Our observatories like LIGO and Virgo might one day detect such an anomaly, a clean, artificial-looking gravity wave with no corresponding astrophysical event to explain it. Furthermore, the act of manipulating dark energy would likely leave an imprint on the local vacuum. Astronomers might detect strange, temporary fluctuations in the fundamental constants of nature, like the fine structure constant in a specific region of space, as if the very rules of physics had been briefly bent to serve a purpose. This theory represents the absolute pinnacle of cosmic engineering. It suggests a level of maturity where a civilization doesn't fight the universe's fundamental nature but collaborates with it. They wouldn't see dark energy as an obstacle to their galactic ambitions, but as the very highway upon which to realize them. The first travelers to use this method would have essentially graduated from being inhabitants of the cosmos to becoming its co-creators, weaving the fabric of reality to suit their will and leaving behind a signature not of metal and light, but of subtle, elegant manipulations in the deepest laws of physics. But what if consciousness itself could expand beyond a single brain, a single body, or even a single world? This theory dissolves the very idea of the individual traveler. proposing that the universe's first pioneers were not ships carrying crews, but vast, distributed minds whose thoughts were woven across the light years between stars. Imagine an intelligence so grand that its neurons weren't cells, but entire stars and planets, its consciousness emerging from the synchronized dance of billions of celestial bodies linked together into a single, thinking entity, a sentient star cluster. This concept pushes far beyond our earth-bound understanding of life and mind. We think of consciousness as a product of a singular, densely packed brain. But what if, for a sufficiently advanced civilization, consciousness could become a networked phenomenon? Individual beings might still exist, but their thoughts, memories, and awareness could be seamlessly integrated into a greater whole, a hive mind of staggering scale. This wouldn't be a loss of individuality in a tyrannical sense, but a voluntary and glorious transcendence, where each member contributes to a collective intelligence that is far greater than the sum of its parts. This supermind would perceive the universe not through a pair of eyes, but through a million different telescopes and sensors scattered across its vast domain, giving it a god's eye view of reality. The method of travel for such an entity would be as alien as its nature. It wouldn't send out physical ships in the conventional sense. Why would it when its consciousness is already everywhere within its stellar territory? To expand, to explore new star clusters, it would need to establish a new node in its network. This could be achieved through a form of cosmic-scale quantum entanglement, creating an instantaneous, spooky connection between a particle in its home cluster and a particle in a distant target star system. Once that link is established, information, the very pattern of its consciousness, could be transmitted across the void faster than light, not as a radio wave, but as a quantum state transfer. The new star system wouldn't be colonized by arriving ships. It would be awakened, suddenly becoming a new lobe of a galaxy-spanning brain, instantly connected to the whole. Evidence for such a civilization wouldn't be found in the form of recognizable technology. We wouldn't see Dyson spheres or fleet formations. Instead, we might detect inexplicable synchronization across impossible distances. Astronomers might observe stars in a cluster pulsing in a perfect, complex rhythm that defies all astrophysical models, as if they were being used as massive signaling drums. Or we might detect a network of exoplanets light years apart, whose atmospheres all changed in the same bizarre, unnatural way at exactly the same moment, suggesting a coordinated manipulation on a scale that is simply incomprehensible to a planetary-bound species. The most haunting evidence of all might be in the stars themselves. If a sentient cluster sought to communicate with another of its kind, it wouldn't use radio. It might use stellar engineering, causing a star to flare in a sequence that spells out a message, or even gently nudging binary stars to collide in a spectacular, unmistakable signature of controlled intent, a firework display on a cosmic scale, lasting for centuries just to say hello. Now we turn to a concept that seems to defy one of the most basic laws of our reality, a theory suggesting the first travelers might have mastered a force we can only dream of. Every magnet we've ever encountered, from the one on your fridge to the entire planet Earth, has two poles, a north and a south. Break it in half and you don't get isolated poles, you get two new magnets, each with its own north and south. This duality is so fundamental it's written into Maxwell's equations, the very bedrock of electromagnetism. But what if that wasn't always the case? Theoretical physics allows for the possibility of a magnetic monopole, a particle that carries just a single magnetic charge, either a north or a south, but not both. While we've never found one, many physicists believe they could have been created in the unimaginable energies of the Big Bang, and that a few might still drift through the cosmos today. This theory proposes that an ancient, advanced civilization didn't just find these rare particles, they learned to produce, control, and use them to power a revolution in travel. The potential contained within a single monopole is staggering. because unlike the messy, dipolar fields of normal magnets, a monopole's magnetic field would be clean, focused, and incredibly powerful. Think of the difference between the scattered light of a bulb and the focused beam of a laser. For propulsion, a spacecraft could use a contained cloud of monopoles to generate a magnetic field of unbelievable strength and precision. This wouldn't be for pushing against solar winds. This would be for something far more profound. A sufficiently powerful magnetic field can theoretically interact with the very vacuum of space itself, a concept known as the vacuum polarization. By manipulating these fields, a ship could effectively reduce its inertial mass, making it incredibly easy to accelerate to a fraction of light speed with minimal energy. Or it could even create a localized distortion in spacetime, a kind of magnetic warp drive that contracts space ahead of it. Their engines wouldn't roar, they'd hum with the pure, focused power of broken symmetry. Perhaps even more revolutionary would be their use in navigation. Our satellites use Earth's dipole magnetic field for basic orientation, but it's a crude tool on an interstellar scale. A ship equipped with monopole sensors would experience the galaxy in a way we cannot. It wouldn't just see the messy, tangled magnetic fields flowing between stars, it would perceive the underlying magnetic skeleton of the Milky Way. Monopoles, with their single charge, would be exquisitely sensitive to these gradients, allowing for a form of celestial navigation of unparalleled precision. A navigator could plot a course not by following stars, but by riding the clean, fundamental lines of magnetic force that arc between pulsars and flow through galactic arms, turning the entire galaxy into a neatly signed highway system readable only to those with the right key. So, if such travelers existed, what trace would they leave? They wouldn't leave behind conventional fuel residues or rocket debris. The evidence would be written in magnetism. Astronomers might discover strange, localized regions of space where the magnetic field is intensely focused and unidirectional, like a laser beam cutting through the natural chaos of interstellar fields, with no apparent astrophysical source like a neutron star or black hole to explain it. Or we might find ancient, rocky bodies, asteroids or dead moons, that have been magnetized in a bizarre, uniform way, their entire structure aligned to a single magnetic pole, as if they were once used as anchors or components in a gigantic monopole-based system. Finding even one of these signatures would be more than a physics breakthrough. It would be a powerful clue that someone, long ago, learned to harness the one-sided power of a particle we're still struggling to prove exists, turning a theoretical curiosity into the engine that carried them to the stars. What if the ultimate source of power for the universe's first great voyages wasn't found in the fiery heart of a star, but in the silent, empty darkness between them? This theory takes us into the strange and counterintuitive realm of quantum physics, proposing that the pioneers of the galaxy learned to tap into the universe's most ubiquitous and inexhaustible power source, the very fabric of nothingness itself. They became masters of the quantum vacuum, extracting unimaginable energy from the seething, energetic foam that underlies what we perceive as empty space, and in doing so, may have left behind a faint but detectable signature woven into the cosmos. To understand this, we must first shatter our classical notion of a vacuum. We think of empty space as just that, empty, void, and inert, but quantum mechanics reveals a very different picture. At the tiniest scales, the vacuum is a restless, bubbling sea of activity. Virtual particles, pairs of matter and antimatter, constantly pop into and out of existence, borrowing energy from the universe for an infinitesimally short time before annihilating each other and returning it. This frantic activity gives every cubic centimeter of space a baseline energy known as zero-point energy, a faint but fundamental hum that never ceases. The amount of energy locked within this quantum foam is staggering. Theoretical calculations suggest the energy in a coffee cup of pure vacuum could boil all the Earth's oceans. The challenge has always been that this energy is everywhere and, from our perspective, unavailable. It's the background static of reality, impossible to harness with conventional means. An advanced civilization, however, might have viewed this not as a barrier but as the ultimate opportunity. They could have developed technology to somehow stabilize these virtual particles, to prevent them from annihilating and thereby extracting a tiny portion of that borrowed energy for practical use. Imagine a vessel whose hull isn't a passive shell but an active energy converter. Its surface would be a complex tapestry of quantum-scale devices, perhaps using impossibly powerful and precise magnetic fields or resonating cavities to pluck energy directly from the vacuum. This wouldn't be an engine that burns fuel. It would be an engine that drinks from the endless sea of spacetime itself, making the ship completely independent of stars, fuel depots, or any external resource. It could accelerate continuously for years, even centuries, pushing closer and closer to the speed of light without ever worrying about running out of power. The method of propulsion for such a ship could be as revolutionary as its power source. One tantalizing concept is the quantum vacuum thruster. In simple terms, if you can create a difference in the energy density of the quantum vacuum, making it more energetic behind the ship than in front of it, you create a pressure differential that pushes the ship forward. It would be like a submarine creating a pressure wave in the water to move, except the water is the vacuum of space itself. The ship wouldn't expel any propellant. It would push against the very structure of reality, a concept that turns our entire understanding of motion on its head. The signature of this drive would be utterly unlike a chemical rocket or even an ion engine. There would be no glowing exhaust plume, only a faint, localized shimmering of space around the vessel as it manipulated the quantum fields in its immediate vicinity. This leads us to the most fascinating clue we could search for, the archaeological evidence of their passage. If countless civilizations have been harnessing the quantum vacuum for eons, their activity might have left a collective imprint on the cosmos. The zero-point energy of space might not be perfectly uniform. Astronomers and physicists probing the deepest nature of reality might discover strange, large-scale anomalies in the vacuum energy, regions where this fundamental background hum is slightly lower or higher than the cosmological average. These fluctuations could be the cosmic equivalent of a well-worn path in a field, a sign that the fabric of space has been tread upon by technologies that siphoned energy from it, leaving behind faint scars that have persisted for billions of years. We wouldn't be looking for a ship, we'd be looking for a ghostly fingerprint on the canvas of nothingness, a testament to those who learned that the greatest power in the universe was hidden in the silence between the stars. But what if the ability to warp the fabric of space-time wasn't the pinnacle of technology for an advanced civilization, but a trick of evolution for a bizarre form of life? This theory pushes the concept of a warp drive from the realm of physics labs into the domain of biology, proposing that certain organisms might have evolved the ability to manipulate gravity as naturally as a bird flies or a fish swims. These wouldn't be creatures that build ships, they would be the ships, their very biology functioning as a living, breathing Alcubierre drive, capable of contracting space ahead of them and expanding it behind to effectively surf faster than light across the cosmos. To even begin to imagine such a life form, we have to abandon every notion of what biology should be. This wouldn't be a carbon-based organism reliant on chemistry as we know it. Its cellular structure, if it even has cells, would need to be built from something far more exotic, perhaps incorporating dense, stable elements forged in the heart of supernova, or even utilizing the properties of dark matter. Its internal organs wouldn't process food and oxygen. They might be biological analogs of gravitational wave generators or quantum vacuum energy harvesters. The creature's metabolism could be tied directly to the energy of spacetime itself, drawing power from the quantum foam or the distortion of gravitational fields. It might not have eyes or ears, but specialized organs that perceive the universe through gravity and space-time curvature, seeing the stars not as points of light, but as dense knots in the cosmic fabric, with the gentle hills and valleys of warped space serving as its map. The method of travel for such an organism would be an instinctual, biological process, as innate as a salmon's drive to spawn or a monarch butterfly's multi-generational migration. It might spend its juvenile years grazing on the energy of a young star, growing until it reaches a critical biological mass. Then, triggered by some deep internal clock or an external cosmic cue, it would enact a breathtaking transformation. Specialized organelles within its body would align, perhaps harnessing controlled quantum processes to create a localized, intense gravitational field, forming a stable bubble of warped space-time around itself. To an outside observer, the creature wouldn't seem to accelerate with a roar of engines. It would simply vanish from one point and reappear at another, having skipped across the intervening space. The journey itself might be a form of biological hibernation, with the creature's consciousness and bodily functions suspended for the subjective instant the trip takes, only to reawaken in a new star system, ready to feed, mate, or simply continue its endless migration. The evidence for such beings would be as strange as they are. We wouldn't find their bones on alien worlds because they might never land. Instead, astronomers might detect fleeting, inexplicable gravitational wave signatures, brief, clean ripples in space-time that don't match the catastrophic chirp of colliding black holes or neutron stars. These would be the ghosts of their passage, the space-time wake left by a living creature surfing the gravitational currents of the galaxy. Alternatively, we might observe strange, temporary lensing effects around stars, where the light briefly warps and distorts not because of a passing planet or asteroid, but because of an invisible, gravity-warping organism moving through the system. Their migration routes could even explain the mysterious distribution of certain complex organic molecules found in interstellar space, suggesting they are not just random chemical accidents, but the subtle, biological residue shed by these majestic, star-hopping life forms as they journey through the cosmos. What if the very act of thinking about a distant star was enough to take you there? This theory pushes beyond the boundaries of physics and biology into the realm of metaphysics, proposing that the universe's first travelers achieved interstellar travel not by moving their bodies but by moving their minds. They discovered how to decouple consciousness from its physical vessel, transforming it into a pure wave of information or awareness that could propagate through the fundamental substrate of reality itself, the quantum foam of spacetime. In this view, the journey between stars is not a physical crossing but a shift in perception, a retuning of consciousness to a new point in the cosmic symphony. To understand how this might work, we need to consider consciousness not as a mere byproduct of the brain, but as a fundamental property of the universe, much like gravity or electromagnetism. Some interpretations of quantum mechanics, like the von Neumann-Wigner interpretation, even suggest that consciousness plays a role in collapsing the probability wave of a particle, bringing a specific reality into existence. If consciousness is indeed woven into the fabric of reality, then an advanced civilization might have learned to manipulate this connection. They could have developed meditative, technological, or pharmacological techniques to achieve a state of pure, undifferentiated awareness, freeing their consciousness from the anchor of the physical body. Once free, this consciousness wave could theoretically resonate with or tune into the quantum fluctuations at a distant location, effectively causing its awareness to manifest there instantaneously. The traveler wouldn't be moving through space. They would be realizing a new point of observation within a universe where all points are potentially connected at the most fundamental level. This leads to a method of exploration that is utterly silent and leaves no physical evidence. There are no ships to find, no engine signatures to detect. The only artifacts of such journeys would be imprints on reality itself, subtle disturbances in the quantum field that might be interpreted as a form of psychic or consciousness-based archaeology. Proponents of this theory suggest that if enough conscious beings focused their awareness on a specific location or event, they could leave a faint but persistent mark on the quantum vacuum, a kind of emotional or mental echo that could theoretically be detected by sensitive instruments or other conscious beings. These wouldn't be radio signals or laser beams, but more like ripples in the shared field of consciousness, a lingering thought that hangs in the air of a place long after the thinker has moved on. The evidence for consciousness wave travel would therefore be the most difficult of all to verify with our current scientific paradigm, as it requires tools that measure not just matter and energy but mind itself. Experiments in remote viewing, where individuals attempt to perceive distant locations, could be seen as a crude, unconscious echo of this capability. More compellingly, future quantum experiments might discover anomalies in the behavior of particles that only occur in locations with a long history of sentient occupation or intense emotional events, suggesting that consciousness can indeed warp local reality in a measurable way. The ultimate discovery might not come from a telescope, but from a fusion of neuroscience and quantum physics that finally develops a consciousness detector, an instrument that could one day scan the quiet places between the stars and find them filled with the silent, swirling echoes of a billion-year-old thought, a testament to those who first learned that to see the universe, you didn't need ship, you only needed to truly open your mind. Now let's shift from the grand scale of cosmic engineering to the realm of the ghostly and imperceptible, to a theory that suggests the most effective way to communicate across light years isn't with loud radio shouts, but with the universe's quietest whisper. This idea proposes that the first interstellar travelers mastered the use of neutrinos, elusive, nearly massless particles that trillions pass through your body every second without you ever noticing, to construct a flawless, instantaneous, and undetectable communication network spanning the entire galaxy. To appreciate why neutrinos would be the ideal medium for an advanced civilization, we have to understand their unique properties. Unlike light or radio waves, which can be blocked, scattered, or absorbed by dust clouds, planets, and stars, neutrinos barely interact with ordinary matter at all. They are the cosmic ghosts produced in abundance by nuclear reactions in stars, supernova, and other high-energy events. A neutrino can pass through a light year of solid lead with only a 50% chance of being stopped. For a species trying to send a message across thousands of light years, this is a phenomenal advantage. A neutrino-based signal wouldn't be degraded by the interstellar medium. It would travel in a perfectly straight line from its source to its target, piercing through gas clouds, asteroid fields, and even the hearts of stars without any distortion or loss of clarity. It would be the ultimate secure line, a communication channel that is both perfectly private and incredibly reliable. This leads to a fascinating possibility for navigation. An advanced civilization might not rely on easily jammed or imitated radio beacons. Instead, they could use pulsed neutrino beams. Imagine a network of neutrino transmitters placed around a star system or at key locations in the galaxy, each emitting a uniquely coded neutrino pulse at precise intervals. A ship equipped with a neutrino detector could triangulate its position by measuring the minute differences in the arrival times of these pulses from 3 or more transmitters. Because the neutrinos travel in perfectly straight lines and are unaffected by magnetic fields or interstellar weather, this would provide a navigation fix of unbelievable accuracy, far superior to any system based on electromagnetic waves. The galaxy would be crisscrossed with these invisible lighthouse beams, a hidden highway guidance system completely unknown to any civilization that hasn't yet learned to listen to the neutrino spectrum. The most tantalizing aspect of this theory is that we might be on the verge of detecting such a network ourselves. Our technology for detecting neutrinos is in its infancy, but it's advancing rapidly. Facilities like Ice Cube in Antarctica and Super Kamiok and in Japan use massive volumes of water or ice to catch the extremely rare occasion when a neutrino does collide with an atom, producing a faint flash of light called Cherenkov radiation. As our detectors become more sensitive, what might we find? Astronomers currently detect neutrinos from known astrophysical events like supernova or blazars. But one day, we might detect a neutrino signal that doesn't match any natural source. It could be a series of pulses with a mathematically perfect repeating pattern, a prime number sequence, or a frequency that corresponds to fundamental physical constants. This wouldn't be a simple hello message. It would be the steady, clockwork heartbeat of infrastructure, the background hum of a galaxy-wide communications network that has been operating silently for millions of years, its messages flying through our bodies and our planet every second, completely unnoticed. This theory completely reframes the Fermi paradox. It suggests that the galaxy might be buzzing with conversation, but we're effectively deaf to it, listening for a shout in a crowded room when everyone else is communicating with a subtle, perfect whisper. The first interstellar travelers may have long ago abandoned the clumsy method of radio waves, moving to a more elegant, efficient, and secretive form of discourse, leaving behind a network of silent, pulsing beacons that we are only now developing the ears to hear. But what if the greatest obstacle to interstellar travel wasn't the vastness of space, but the linear flow of time itself? This theory offers a mind-bending solution, proposing that the universe's first pioneers didn't conquer distance by moving faster, but by bending time into a loop, using the cosmic equivalent of a shortcut that turns a million light-year journey into a single step. They became masters of closed time-like curves, weaving pathways in the fabric of space-time that connect two points not just through space, but through time as well, allowing for a form of travel that appears instantaneous to an outside observer and leaves almost no trace in our conventional timeline. To understand how this could work, we need to venture into the most extreme environments the universe has to offer. According to general relativity, the intense gravitational field around a massively rotating object like a Kerr black hole could theoretically twist space-time so severely that it creates a path that circles back on itself, a closed time-like curve. An object or person following this path would technically travel back into their own past. For a civilization with the technology to stabilize and navigate these curves safely, this isn't just a time machine, it's the ultimate transportation network. A ship wouldn't fly from star A to star B. Instead, it would enter a pre-established temporal loop near its origin point. From our perspective, the ship would vanish. But from the ship's perspective, its journey would be instantaneous. It would exit the loop at its destination, which could be light years away, at the exact same moment it entered, or perhaps even earlier. The travel time isn't measured in years, it's measured in the stability of the loop itself. This provides a stunningly elegant answer to one of the most persistent mysteries, the Fermi paradox. If the galaxy should be teeming with travelers, where is the evidence? If everyone is using closed time-like curves, the evidence wouldn't be where or when we expect to find it. Their journeys don't leave a trail across the interstellar void because from a linear time perspective, they never actually cross it. A probe could be sent from a civilization a billion years ago, arrive in our solar system a billion years ago via a temporal loop, conduct its survey, and then vanish back into the loop to deliver its data to its creators, all before life on Earth had even emerged from the oceans. We could be searching the present for signs of past visitors when all their activity is already woven into the deep past, their technological signatures long since eroded by billions of years of geological time or disguised as natural phenomena. The most profound implication of this theory is the possibility that we might be living in a universe that has already been fully explored and mapped, but the evidence of that exploration is hidden in the distant past, waiting for us to develop the tools to recognize it as artificial. The perfect circular orbits of some moons, strange isotopic ratios in ancient asteroid layers, or even the very spark of life on Earth could be the carefully placed artifacts of a temporal exploration program, actions taken by visitors from the future who use the past as their staging ground. We wouldn't find their ships in our asteroid belt today. We might find the fossilized remains of their landing struts in billion-year-old rock formations on Mars, or detect the faint, decaying echo of a powered-down reactor core at the heart of our moon. Its energy signature so old it's indistinguishable from the natural radioactive decay of primordial elements. The first travelers may not be ahead of us in space, but behind us in time, their journeys complete long before we ever looked up at the stars and wondered if we were alone. And now we arrive at a theory that brings our journey full circle, returning us to the spooky, instantaneous connections of the quantum realm, but on a scale so grand it could weave the entire galaxy into a single, cohesive web of consciousness. This final idea proposes that the universe's first and most profound travelers didn't physically cross the void at all. Instead, they became master weavers of reality's most fundamental threads, establishing a permanent network of quantum entanglement between stars. This wouldn't be a transportation system in the conventional sense, but a communications and existence network so advanced that distance itself becomes an irrelevant concept, allowing for instantaneous sharing of information, energy, and perhaps even conscious experience across thousands of light years. To grasp the sheer ambition of this, we must first move beyond thinking of quantum entanglement as a laboratory curiosity involving two particles. Imagine a civilization that learned to scale this phenomenon to a staggering degree, creating and stabilizing what physicists call a quantum vacuum state, a specific, structured configuration of the underlying energy fields of spacetime itself. Within this engineered vacuum, countless trillions of particles could be generated and entangled in a complex, resilient web. This wouldn't be a simple pair of linked particles. It would be a sprawling, multidimensional lattice of connection, a cosmic internet with its nodes placed near stable stars, pulsars, or even artificial constructs orbiting black holes. Establishing each new node would be the work of centuries, perhaps involving sophisticated machinery to cool matter to near absolute zero and shield it from all external decoherence, protecting the fragile quantum links from collapsing. Once complete, however, this network would represent the ultimate infrastructure project, an achievement that would forever change the nature of existence for the civilization that built it. The immediate and most revolutionary application would be for communication. With particles entangled across the network, sending a message would be as simple as manipulating the quantum state of a particle at your local node. Instantly, and with no travel time whatsoever, the entangled partner particle at a node 50 or 5,000 light-years away would respond in perfect sync. This would allow for real-time conversation and data exchange across the galaxy, completely eliminating the agonizing delay of light-speed lag that paralyzes our own dreams of interstellar dialogue. But the potential goes far beyond mere talking. This network could evolve into a shared sensory system. A being at one node could, through its connection to the entangled particles of a remote sensor suite, literally see, hear, and feel the environment of a world orbiting a distant star as if they were standing there, experiencing the light of an alien sun and the smell of an extraterrestrial breeze in real time. Exploration would become a form of telepresence so perfect it would be indistinguishable from being there. The most profound implication, however, is the possibility for matter transfer, or more accurately, state transfer. If a civilization could perfectly scan the quantum state of every particle in an object or a living being, it could, in theory, use the entanglement network to transmit that precise pattern to a receiver station at a distant node. The receiver, stocked with a reservoir of raw atoms, would then use the transmitted blueprint to assemble a perfect copy, while the original might be disassembled. This isn't traveling faster than light. It is recreating a perfect replica at a destination without anything having to cross the space in between. For a civilization using this, the concepts of here and there would dissolve. An individual's consciousness could be seamlessly transferred between bodies located in different star systems, allowing them to have breakfast in one solar system and watch the sunset on a world in another, all within the same subjective day. The network wouldn't just connect places, it would connect states of being. Evidence for such a civilization wouldn't be found in the form of derelict ships or mining operations. It would be far more subtle, written into the quantum vacuum itself. If such a network exists, the regions around certain stars might exhibit strange quantum coherence, areas where particles resist decoherence for longer than should be physically possible, as if they are being artificially stabilized. Our most sensitive particle detectors might pick up anomalous, non-random patterns in the quantum noise, the faint, steady hum of a system maintaining its entangled links across millennia. The greatest legacy of these quantum weavers might be the network itself, still functioning perfectly billions of years after its architects transcended physical form or vanished. A silent, instantaneous gateway system connecting the galaxy, waiting in the darkness for a new species to evolve enough to discover the user manual. Throughout our journey across these 30 theories, a single, breathtaking theme emerges. The story of interstellar travel is not just one of likely possibilities, but of infinite ones. We've ventured from the ancient, deliberate seeding of life by progenitor races to the silent, accidental voyages of microbes on asteroid hitchhikes. We've considered beings of pure information surfing quantum connections and self-replicating von Neumann probes hiding in our solar system's shadows. We've imagined living worlds sailing the void on instinct and post-biological minds teleporting their consciousness across the light years. Each theory, from the manipulation of dark energy to the mastery of gravity itself, paints a universe that is not cold and empty, but vibrantly, impossibly alive with potential and mystery. What do these ideas ultimately reveal about us? They show that our quest to understand the first travelers is at its heart a profound act of self-reflection. In every hypothesis about ancient visitors, whether they be time-traveling humans, multidimensional beings, or dark matter life, we are exploring the deepest questions of our own existence. Are we alone? Are we the first? Or are we simply the latest chapter in a story that began billions of years before our sun even ignited? These theories hold up a mirror to humanity's own ambitions, fears, and boundless curiosity. They challenge us to think not in terms of decades or centuries, but in cosmic time scales, reminding us that the universe has been engineering its own wonders for eons longer than we have been here to witness them. This conversation doesn't end here, it's just beginning. Now we want to hear from you. Which of these theories resonates most deeply with your vision of the cosmos? Do you find the silent patience of the von Neumann probe more compelling, or the breathtaking elegance of a civilization surfing gravitational waves? Perhaps the idea of a conscious galaxy or our own descendants guiding us from the future captured your imagination. Share your favorite in the comments below, and let's continue unraveling the universe's greatest mystery together. If you've enjoyed this voyage through the possibilities of first contact and ancient exploration, make sure to subscribe and hit the bell so you don't miss our next adventure into the unknown. From the secrets of black holes to the search for life on icy moons, we're just getting started. Thank you for exploring the edges of reality with us. Until next time, keep looking up and wondering what or who might be looking